Hello everyone, this is V. Manikyala Rao, working as Assistant Professor in the Department of CSE and ML in BURIT Narsapur. Now, today we want to discuss about another data pre-processing technique, that is data reduction. So, the name itself we know. Reduction means we need to reduce the unnecessary things in the given data to reduce the space in the computers. So, for that what we are doing means we are having different types of techniques to do this one. So, coming to the first one, dimensionality reductions. Here, the dimensions means the number of columns is to be removed from the unnecessary columns is to be there in the given data set, means that data set values is to be removed. For example, in the dimensionality reduction, I will consider the name, age, color, next feedback, salary, some sports, like this. These are the different dimensions. That means these are the different attributes are there in the given data set. So now by using dimensionality reduction, what we have to remove means we will remove the existing attributes that will not reflect on the given data set. So see here, the name is compulsory one. Based on the names only we will identify the given data set, and based on that age also we need to identify. Age is also not a constraint. We will remove the age that will not reflect on the given data set. So the color also that will not reflect. Why? Because the color, based on the color we can't identify that one. We will identify that one based on the names. Now coming to the sports. So based on the sports also we are not calculating that one, or based on the feedback also we are not calculating. So by using these all the attributes, by using dimensionality reduction, what we are doing means we need to remove this. Here we are having total 6 type of attributes are there. So out of 6 attributes, we are reducing that 6 attributes into only 2 attributes. So based on the name and the salary, we need to identify the given person and what are the features of the given person. Everything we need to identify by using the dimensionality reduction concept. Unnecessary attributes that will not reflect on the existing data set, that will be called as dimensionality reductions. Now coming to the numericity reduction. So coming to the first one, sampling. Numericity reduction means it is used to reduce the given things. See this example. So they are given this location, some ny along with the LAS are to be there. So what we are doing means they need to reduct the numericity. See, so they are having 24, 35, 28, 40 and 30. So what we have to do means I will consider 24 to 30 is one constraint. Next 35 to 40 is one constraint. So based on the age constraint we need to differentiate. 24 to 30 means the constraint is 1, 2, 3. So these 3 values comes under this one. The first row, second row, third row and fifth row comes under these 2 things. Placed into the cluster. We are reducing the space. The total 5 set of rows is to be divided into only 2 set of rows. So here the next 2 things are 2 and 4. Like this we need to differentiate into the sampling. Sampling means that is used to distribute based on the whatever the features we are taken. Or otherwise we have to take NY and LA. So based on that we need to differentiate this one. So we have to. So actually we are having total 5 items are there. We are distributing that 5 items into 3 and 2. So it will occupy only 2 rows of memory sets in the given computer space. So that is called as numericity reduction. Next one, clustering. So clustering means it is used to combine the similar or near data of values into a group of clusters. So see here. So we are taking 3 types of ends. First one is high end. Second one middle end and low end. High end means the near highest values we need to consider. So highest values in this is 1100 and 900. These two are the near values, highest values. So now we will combine those 2 values, laptop and TV. So 1100 plus 900 divided by 2. So total 2000 by 2, that value is 1000. So that average value means 4.2 plus 4.5 by 2. So that is 4.35. Similarly, next middle range. So middle range value is these 2. 500 and 600. These 2 are the middle range values. So now we are taking that 500 plus 600 divided by 2, so that is 550. So that average 4.2. This is 4.3 plus 4.1 by 2, so that is 4.2. So next, similarly, the next middle, the last low end value is 150, so that relating is 3.9. So we are combining the similar type of ends into a group of clusters. So that is about clustering. Next one, aggregation. Aggregation means it is used to combine the given things into a smaller set of things. So see here, we are having the different regions. Here we are having NY and here we are having LA. So aggregation means we need to reduce the number of columns into a smaller number of columns. Actually, we are having total 4 columns are there. 4 rows or 4 columns. 4 rows are there. So along with this, we are combining. So NY means we need to combine these two. 5000 plus 3000, 8000. Next, these two, 7500. Aggregation means reduce the number of columns into number of rows into a smaller number of rows. So that is about aggregation. And now coming to the next one, wavelet transform. So wavelet transform means it is used to reduce. Actually, this wavelet transform is used for the 24 hours in a day. So actually we have to represent the 24 hours means that is not possible to represent in the data set, and it will take more time to execute that one. So now in this, what we are doing means we are reducing the 24 hours of time into some smaller set of hours. So see here, I taken, these are the 24 hours of time we are taken here. So that 24 hours is to be divided into 3 hours. So first we are taken the numbers like this. So 0 to 2, that number, the sales values we are taken. Like that we are distributing into the numbers. So see, 0 to 2 means 3 numbers we are taking. Actually total 24 are there. So we are dividing the 24 into 8 blocks. So that's why 3 numbers we need to combine. So like this we are combining. So first 3, 5, 7 and second 8, 9, 4 and next 6, 10, 12. Like this we are representing the values in this. So after representing that one, so we are dividing the 24 hours of time into only 8 values. These are the 8 values we are given. That is called as wavelet transform. We are transforming multiple values of data into a smaller values of data based on the constraint whatever we are taken. Here the constraint we are taken as 24 hours of time in a day. So we are splitting that one into the 24 hours of time, and in that we have to split that one into 3 values, and we are converting the 24 into 24 divided by 3, so that is 8. Reducing the 24 into 8 set of values. So that is about the given wavelet transform. These are next one. Principal component analysis. So principal component analysis means it is used to reduce the given components whatever we are given, and based on this one we need to reduce the given values. In case large set of data is there means we need to identify that large set of data and removing those large set of data into this one. So now see here, first one is combining the existing attribute into smaller number of new variables. That means we are combining the given thing into the smaller set of values. Next, we need to calculate the z value by using the normalizing of data, and then we will calculate the standard deviation. Sigma means standard deviation value. So now this is the data set they are given here. So based on that we are calculating this z value. So how we are calculating this z value means z is equal to x minus mu by sigma. So now we need to know the value of x. So x value is this one. These are the x values. Next, mu values is the mean value mu. How to we are calculating mean value means mu is equal to 85 plus 78 plus 92 plus 70 plus 65 divided by 5. So finally we got that value 78. So like this we are getting the mean value like this. So after calculating that one, next we are calculating sigma value. Sigma is equal to square root of 1 by n minus 1. So n value is 5. So total 5 values are there. 5 minus 1 into sigma equal to 1. So that means the sum of all the values into xi. Xi means this sum value, this total sum value, that xi minus that mu value is 78. Means 85 minus 78 whole square plus 78 minus 78 whole square. Like this, we will execute all those. Finally, we got the sigma value as 10. Like this, we are calculating the standard deviation value. So after calculating that one, so we need to find out the z value. So z is equal to x minus mu by sigma. So x value is what? 85 minus 78 divided by 10. So that is 0.7. That is z value for A. Like this, we are calculating these values. After calculating these values, now we are differentiating to calculate the covariance between the two variables x and y. So that is xi minus x bar into y minus y bar. X bar is the mean for x. Y bar is the mean for y. So then we are calculating the mean for x and mean of y. So similarly, without calculating also, we are writing these all the values. So those values is compulsory. This diagonal value is 1. This diagonal value compulsory should be 1. Other all the values after calculating we are implementing in the formula. So that is about the principal component analysis for this one. The next method is attribute subset selection. So attribute subset selection means here we are having two types of methods, forward selection, backward selection. So now forward selection means, for example, we are having the attributes. So see here, we are having the attributes, 6 attributes are there initially. So first what we have to take means, first we need to take only one attributes. Out of all the attributes, first I need to choose only A1. First I need to choose only A1. Then I need to insert A1, A4. Then I need to insert A1, A4, A6. Like that we are inserting values. So finally our attribute set are A1, A4, A6. So the 6 set of elements is reduced into 3 set of elements. So now how we are written these values? Actually, we are having A1, A2, A3, A4, A5, A6 are there. For example, A1 is name, some color, age, some blood group, some favorite, movie, name, 1, 4, 5. The last one is feedback. So we are inserting A1, A4, A6. So see here. So I want to take A1 as name, A4 as blood group, and A6 as feedback. I need to include only these attributes into this one. That is forward selection. Out of 6 attributes, we are taking these 3. Based on these 3 things, we need to identify the particular person from this one. So that is about the forward selection. Backward elimination means out of all these elements, we need to remove the unnecessary elements from this, from backward, from back to first. So first I want to remove this feedback. So here, see here, first they are taken 6 elements and then next they are deleting A2. So that A2 is color they need to remove. This is not reflect on the existing data set. That's why we need to remove this color value. So then we are taken A3 is removed from the structure. A is also we need to remove from the structure. Then A1, A4, A6. So finally we are removing the A5. So A5 is favorite movie name. So this one I need to remove. So if you are removing these all the things, that will not reflect on the existing data set. So that is about the given backward elimination and forward selection. So based on that, so that the A1 we need A4, we need A1, then they need to represent the class 1. So it is not reflected means the class 2. They will go to the class 2. A1, A4 in this set means they need to represent the class 1. In case those two are not, this one present, this one not present means that is belongs to class 2. Here also same thing. A4, A6 is belongs to same thing. Here it is no. So that belongs to class 2 and here it is no. It contains yes means that is belongs to class 1. So finally our thing is the A1, A4, A6 belongs to class 1. The other thing belongs to class 2. So that is about attribute subset selection. Next one, based on these all the things, how to frame the decision tree induction. So decision tree induction means the highest value in this. So we are taking the highest value is the A6. Based on the value, highest value we are taking, and then it contains 2 types of values, that is yes and no only. So that's why the purchase history is to be divided into yes and no. Then if it is yes, then that will go to the income 50,000, and if it is no, that class is no to no. Like that we are distributing, and finally we are distributing this one. So actually here we are having different types of incomes are there. That's why we are taking the values greater than 60,000 and less than or equal to 60,000. Greater than highest value means that is belongs to yes, and lesser values means that is belongs to AG1. And then that will go to greater than 25 and that is less than 25 belongs to this one. Highest values means that is in the success case, and lowest values means that is in the failure case. Now these are the other elements. This is the fifth one, regression models. So regression models means we are having different types of regression models are there. That regressions are logistic regression, linear regression. By using these all the methods, we need to differentiate the given variables whatever we are taking. So actually linear regression means that is y is equal to mx plus c. So this is the independent variable, this is the dependent variable. Why? Because when we are changing x value, the y value is also changing. So that's why it is a independent value. Independent value. When we are changing x value, the y value is also changed. So based on that, regression models we need to implement. Next one, histograms. Histograms means it is used to divide that one into visualized part. So I will show you the histograms. Sixth one. So like this, we are differentiating in the visualized part. These all are called it as histograms. For example, this is 10, this is 20, and this is 30. So 10 belongs to all the correlation values, that is belongs to y. This is y, this is x. And 20 related, all are related to y. Then 30 related, all are related to y. So like this, we are differentiating the values into the histogram. Next one, clustering. Clustering means the similar group of similar items is placed into a similar clusters. Just like for example, 10, 20, 30, 40, 50 is there. Total 5 values are there. We are taking the highest value, middle value, and lowest value. So highest values are 40, 50. So 40 plus 50 by 2, 90 by 2, 45. Next values are 20 and 30. So 20 plus 30 by 2, 25. Then the lowest value is 10. So actually we are having total 5 values are there. By using clustering technique, what we are doing means we are reducing these 5 values into a only 3 values. So values are 45, 25 and 10. So that is about clustering. Next one, sampling. Sampling contains two types of things. First one, simple random sample without replacement, simple random sample with replacement. So I will show you those two things in the picture. So see here, simple random sample without replacement. That means they are having only unique elements. So T5, T1, T8, T6. These are the unique transactions they are taken. See here, simple random sample with replacement means here the T4 is there. Here the T4 is there. Here also the T4 is there. The repeated type of transactions we need to include. That is called as simple random sample with replacement. Simple random sample without replacement means it is used to take only unique values. This example also same thing. So start with that one. So we are dividing that one into the youth, middle-aged youth persons, middle-aged persons and the senior persons in this. So simple random sample without replacement with replacement means, so the unique just like T38, T256, T307, T391, uniquely all the values are to be placed. That is called as simple random sample with replacement. Without replacement. Simple random sample with replacement means the same value we need to take. So T307 is also there. And again we are taking. This is called as simple random sample with replacement. The same values we need to take. Without replacement means we don't want to take this the same type of values into this one. That is about the two methods. And now coming to the last one, cluster sampling. Cluster sampling means I will show you. So cluster sampling means it is used to cluster the given type of samplings into a single clusters. So now coming to this one, the last one in this data cube aggregation. So data cube aggregation means the given values, the multiple set of values. Actually, this is one cube. second cube and third cube. Second cube and third cube is there. By seeing this picture, we can't understand the exact values. We see this 2008 values only is to be visible. The other values is not visible to us. So that's why they are taken the complete sales of these things 2008, 2009 and 2010 and split that one into the given things. So in the 2008, these are the home appliances we are taken with the home entertainment purpose 568, 750, 150 and 50. These are the things like this. In the 2008, these values. So similarly, some 400, 200, 100 and 51. Here, some 300, some 200, 150, 1050 and 55. Like this, values are to be taken and represented in the form of cube. So this is about the data reduction techniques. By using these all the techniques, we need to reduce the given data based on the given data sets. This is about the data reduction. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.